Okay, we'll go ahead and get started, even though there's not a whole lot of people on here. So what I wanted to do was go over some of the basic JavaScript, objects inheritance, and a little bit about how that works, so you get a better understanding of the core of JavaScript. I believe that will actually help in debugging Angular and Wismo, and even writing some of your own code. So I'm going to try to go fairly slow with this and show a lot of examples. If you have a question, please stop me and we'll go over anything that you may not understand or you want to see a little bit different. So what is JavaScript? JavaScript is an interpretive programming or scripting language. So JavaScript is an actual scripting language, unlike C# or Java, that is more of a procedural language. This is very much a scripting language. The true name of it is ECMAScript. We are on version 5 right now, with version 6 coming out very soon. You'll see several projects where what will happen is it will take ECMA6 scripting and we'll convert it into ECMA 5 so that modern browsers can use it. Chrome now has some more native support for ECMAScript 6. One of the interesting things is with ECMAScript 6, one of the things that's happening is a lot of OO programmers are coming into JavaScript and get very, very confused on it's not like Java or not like C#, and so they don't like it. So they're trying to make it more Java-like, more C#-like. Where if you take Java and C#, both those languages, there are a lot of people that want to make it more like a scripting language because they don't like it being so procedural. So you're seeing a lot of things like Groovy and some of these other sub-projects that you write in a more of a scripting language and then it gets compiled into the bytecode that needs to be put in. So I just find it interesting that both sides are trying to change the other group's language just because they don't like it. JavaScript is a prototypal language with dynamic typing and first-class functions. I'll go over what prototype language means. The dynamic typing is just simply that we don't have strict typing of variables, and so once you set a variable, it doesn't have to be that throughout the application. So if you set something as a string to start off with, later in the application you can actually change it to a number or a function, and JavaScript doesn't care. Then a couple of little things here is that JavaScript only has objects and primitives. In reality, it only has objects. There are no classes in JavaScript, so you do not have a true constructor with defining the level of access you have on a object like you do in a class language such as Java and C#. And generally, JavaScript runs in the browser, but now there are some server-side versions of the JavaScript engine. Probably the most notable one is Node.js right now, but there are some others out there running different JavaScript engines. Some of the features of JavaScript is imperative and structured. So this is just like any other language that you'll find where you have if-else statements, looping constructs, and ways of defining variables and how a application or how a object has to be structured. Is prototype based. We'll talk about that here in a minute. Dynamic typing, which we just talked about, is object based, and it also has some regular expressions, which is very nice when doing searches and stuff, arrays, object literals, and it is a delegation language. So here are the data types in JavaScript. You have basically three primitive types: a string, a number, and a boolean. Then you have objects, which is a reference data type, a function, which is actually an object, but it's a special type of object. You have arrays, which is also an object, but a very special type of object. and regular expressions, which are a type of object also. So if you look under the covers, and we'll do that here in a little bit, even string, number, and boolean are technically objects. They are just objects of a primitive type. So a variable that contains null contains no value, no string, no number, no boolean, no array, no object. You can erase the contents of a variable without deleting the variable by assigning it the null value. Conversely, you have an undefined value is returned when you use an object property that does not exist, or the variable that has been declared or has not been declared but never had a value assigned to it. One of the interesting things with JavaScript, though, is that undefined, since it is a data type, you can actually take a parameter or property and set it to be undefined, which is different than other languages where you don't have undefined. So if you have an object that is, say, car, and you have a .name, and it's never been assigned any data type, it will come back as undefined, and that is different than null. Null is just simply how you would define null in any other language. It's just no value in there, but there is a underlying property set up there. Any questions on data types? Okay, so one of the things I do want to stress here is that these top three are primitive data types, and the rest are reference data types. In case no one knows what that means is that if I set up a string and then I assign another variable to that string, when I look at those two strings, x is JSON, y is JSON. If I now set y is equal to none, you can see now y is none and x is JSON. That is because primitive values are passed by value. They are not passed by reference. So if you change one, you're just changing the values of it. Where with objects, it's a little bit different. So if I do a var x is equal to this object, that's a dot name, what am I missing? Oh. There we go. Now I set var y is equal to x. I do x.name. You see that says none. Y.name. That is none. But if I say y.name is equal to some such, y.name is now some such, and x.name is some such. That is because when you create an object, you're actually just creating one object and a reference pointer to that object. And so when you set var of y is equal to x, all you're doing is setting the reference pointer of y to the object that x is also pointing to. So what is any questions on the difference between pass by value and pass by reference? It's very similar to other languages. Just know that you only have three objects or three data types that are passed by value, and that's string, number, and boolean. Okay, objects. So in JavaScript, pretty much everything is an object, and what an object really is nothing more than a key value pair of items, and the keys are string and the associated with a data type. Primitives are passed by values and objects are passed by reference. And so here's a very simple object. You have three properties on this object. One is a string, B is a number, and 3 is a function. So when you actually look at this data map, the simple object, this is how it actually looks, is on the left-hand side is the column is the key, which is a string, and on the right-hand side is the associated value for it. What that means is you can do some interesting things with JavaScript that you can't do with some other languages. So I want to take this object here, the simple object. Huh. Oh, that's my problem. There we go. Okay, so I've created a simple object. So as you would expect in most object-oriented languages, I now can go simple object.a, and I have my text, or I can go simple object b, and I have my init, my number that I created. But since all an object is a string value pair, I can actually do this. I can do a string object with an array and pass in the string value that I'm looking for, and it will give me that exact same value. Same thing with B. Okay, so that shows the nature of an object of being nothing more than a key value pair when you can actually find your parameters or your parameters based on an array looking at the tree map. This makes it very convenient when you want to dynamically search for certain things in your object. You can actually just pass in a string value, do the array notation, and find the object that you're looking for. The creating of an object, when you actually create the object, it will also create two other keys that are hidden from you. It will construct a constructor function and a protottype object. The construction function is just as it sounds. It's an actual constructor. I'll show that to you in a minute. And the prototype is basically kind of like a linked list for the objects that you have in JavaScript. And this is how JavaScript handles inheritance. So how do you create objects? So there's two ways in JavaScript to create objects. You have the top way of creating an object as a function, or the bottom way is to use the JSON notation to create that object. So we created two objects here, or created objects here. Let's talk about a little bit of the differences. So in the top, you can see we create a function, and we have the ability to pass in parameters. This will overwrite the constructor key and add those values into your object and create a function that you can call to create your object with a constructor. Next thing you know is to define things on, define parameters on my object, I have to use the this dot and then the name of the object that I want, name of the parameter that I want to create, and then equals followed by a semicolon. Strictly speaking, the semicolon is not needed, but it is good form to always add the semicolon. In the JSON object, you'll see that when we create the object this way, we define a variable and we make it equal to the object structure, and we actually create a JSON object basically that gets converted into an object. So you see we'll have name colon object2 and display as a function that we defined, or method type structure that we define on our object. There is one other slight difference, and that's this. Is when you create an object by function, you actually have to use the new object or new name of the object to create this object. So down here at the bottom, you can see we created a raw template, and we created my new object in template display. Well, when you use the dot notation or the JSON notation, you can use it immediately. You can use dot display. So I want to show that real quick. So I'm going to take my function here, paste this in. Now, if I try to do my object dot display, you can see that my object is not defined because you actually have not created this object. So if I do a vol test, now if I run test display, you can see it printed out the console of object 1 is the object. One of the things I do want to show you is when I do test here, you can in Chrome you can see some of the key value pairs that got created. So when I created this object, you can see here it created this constructor. If I had added any parameters to my function, then this constructor would take that function and allow you to create the object. You can see display here, name. The one thing you are missing in here is protottype. The reason why we are missing that is the protottype is actually null. And so one of the things that JavaScript does is, or Chrome does, is that if you don't have the object yet, then it will not show you that object. Now if I take this bottom one, now we create this object. I can now say my object.display. You can see it says object2 literal object. When you create an object using the JSON notation, that is usually called a literal notation for creating an object, where the other one is called functionally creating an object. Okay, any questions about creating an object?
Yeah, in what circumstances should you do either one? When should
so,
yeah.
if you need a function to have a constructor, then 9 times out of 10 you will actually use the function way of creating it. So if we do something like this, what I hate about this. Okay, so what I've done here is I've created a new object. Well, I have an object that I can create with a constructor on it. So now if I say, well, temp is equal to new fun, and now I go temp dot display. Something didn't quite work right there. What happened?
I think you didn't new it. You didn't new fun.
Oh, that's, yep, you're right. I didn't quit my problem with calling it a new function. All right, now, so temp, there we go. That looks much better. Oh, okay. All right. Yeah, I made a mistake there. 'Cause I'm displaying myself there. So let's do this. Let's go. This is actually supposed to be display test. There we go. Now this should work. There we go. Okay, so you can see the that long delay there is to be able to create a function or to create a constructor. The function is the best way to do that. Now, one of the things that you'll find though is, like I said, I have this constructor key there. And so if I really wanted to, one of the things I can do is I can do vol xx equals my dot notation, and then I can say xx dot constructor is equal to, and I am going to copy this. Okay, so now what has happened is, since I created that constructor, if I now do a vol yy equal new xx, I don't know why that didn't work. That should have worked. I'm not 100% sure why that didn't work. But if you overwrite the constructor, you can actually then write constructors using the JSON notation. It's not usually good to do it that way, because one of the things that can happen is, depending on how you have things linked together, it could get overwritten by accident. And you can see here, you can actually overwrite the constructor anyways. So if you're going to use, if you have items that you need to pass into your object to set it up, it's usually better to use the function. Okay, any other questions? Okay, so now what I want to do is talk a little bit about prototype and what prototype means. Prototype is how JavaScript handles its inheritance. So let's show some examples of that. So I have an object here called vehicle. And what I'm going to do is I'm going to create a child of this called car. So you can see here in the bottom piece, if I take car dot underscore underscore proto underscore underscore equal to vehicle, car will essentially extend vehicle. So let's show how that works. So let's take vehicle, and we'll create that object. And I know there's a couple of, so we'll take this. Now we create a new car object. So now if we do a car.name, it's undefined. If I do vehicle.name, you see it says none. If I do vehicle display name, my function, you can see none is none. So it displays the console item of that. But now what I want to do is I want car to extend vehicle. In Chrome, Firefox, and Safari, you can actually get to the prototype object this way by saying call dot underscore underscore proto underscore underscore is equal to vehicle. So now if I say call dot name, it says none. If I do call dot display, you can see it says name is none. So what I've done is extended call will extend vehicle now. So if I look at the call object itself, hopefully, yeah. So you can see my object actually does not have anything in its key value pair. All it really has is the proto object. And inside the proto object, you actually will see a reference to this vehicle object that I've created. So you have display and name here. So just like in any good JavaScript or any object-oriented language, I can come in here and say call.name is equal to Mustang. Now if I say call.name, it will say Mustang. If I do vehicle.name, it will say none. And if I do call.display name, it say my name is Mustang. Okay, so this is acting how we would expect a object-oriented language to work. One little caveat though is in IE, especially 9 and below, they hid the proto object, and so you actually can't get to it. But luckily, Ecomec 5 version, they're giving you the ability to do an object.create. So if I take this line, hopefully everything's about right. Now, that is the exact same thing as what I've done before, but one of the things that object.create does is it will do some creation of a lot of things underneath the hood. If it has information that needs to do stuff with, it will actually add a constructor if you need it. It will add the protos and stuff like that. So this, object.create in the parent is normally how you will want to create objects. Another way of creating an object that you'll see is if I come in here and say null, you can see it basically gave me a undefined object that is completely empty and void. So this is really no different than doing the other two ways of creating an object. It's just it gives you a blank, empty, null object. Okay, let's go back and add vehicle back into there. Okay, so one of the things that you'll find though is this gives you the ability to do some very interesting things. So say besides this car, I also have a truck. Okay, so now if I say truck.name, it is none. Okay. Now say I decided that inside of my car object that for all vehicles we need to actually have a different name. One of the things I can do is I can say call.prototType.name is equal to new name. Why is that not working? That was working over there. Huh. Okay, I'm not for sure why prototype wasn't created there. Oh, I know one thing I can do is oh well. If I go into vehicle, give it a new name, and then I do call.name. You can see it has a new name, and truck is the same way. Okay, but now if I go into call.name, look at truck name, it says new name, and call name is Mustang. Okay. When I create, if I come in here and do vehicle or truck, and do a new one. Now if you go to call.name, you can see that it didn't actually touched it. Even on truck, it then gives you a new one. So you can actually define some values on there. I'm not 100% sure why protottype's not working right now. Yeah, I must have something mistyped or something. The reason why I was going to show that is because one of the things that you'll find a lot in the JavaScript world is if I create like a string and now I do a console.log of test, you can see that it prints out the string, it prints it out real nicely. But this is nothing more than a regular object. And so if I do test.protottype, and let's give it a new function. It just prints out the values of this. Okay, something is wrong with my console right now. I'm not 100% sure, but when you do prototype like this, what it will do is it will look into proto object and actually add values to it. This gives you the ability to extend other objects, and so you'll find it a lot on arrays and strings, where people want on every string, on every array, for that to be able to be used. And so one of the ways you do that is you actually go onto the prototype object and you will actually do something with that. Like I said, I'm not 100% sure why this isn't working, because I just tested it earlier on another piece and it was working just fine. So it might be a version I have downloaded. But let's see what's going on here. So when you look at that object, we have a function, and that function is technically just an object. Now, one of the things about functions that are different than a normal object is it will also create two key values here. One is name, which will be the name of the function, and one will be the length. Functions, though, also have a proto, and so you actually can extend functions with other functions. So here's our vehicle, and so you see on our vehicle we have two values, a name and a display name. The display name is a reference to the function object, and then it has a proto. When we look at call has nothing in it except for a proto, and it is linked to a reference to the vehicle object. So the way JavaScript works, let me go back, is when you do a call.name, what it's going to do is look at call and decide, do I have a name value on my key value pair? No. So what we'll do then, it will go into the prototype object and look and say, is prototype null? If prototype is not null, then look in its object to see if I can find my name key value. And so in this case, it will go into vehicle, go to name, it will find name there, and then that's what it will actually display. Okay. Same thing with display on function. So you can actually chain these really long. If you chain objects in a long string, long chain, but a lot of your values are on your base object, you can get a performance hit on that, because on your child, especially if it's like 5 or 6 objects deep, it has to go up that tree constantly to find the actual values that it's looking for. So one of the things you have to be careful about in JavaScript is making sure that you don't have real long prototype linking trees. That's very short. Another thing is, so if I have truck here, this looks just like car. Remember, it's a reference that is pointing to vehicle, not the actual object itself, but just the reference. So here's an example of, we're going to go over an example of what this does. So let me copy this information to be able to show this. Interesting. Okay, so what I've done here is I've created 3 objects: a vehicle object, a car object, and a forward object. The car will extend vehicle, and forward will extend car. So this acts just as you would think. You do forward.name. Let's try this again. Click my vehicle first. Click my car. And let's click my forward. There we go. So you can see there when I do forward.name is Mustang, but yeah, if I go into vehicle, it will be none. Okay. Now one of the things that I have done here is you can see up here on my vehicle I have a return this.name. The reason why I did that is one of the things you have to understand about this is the object that is actually called. It's not the object that's in. So the first thing that will happen when I call forward.getName, and let's actually show that real quick. You can see that displayed Mustang there, because what we're doing is we're taking the this.name in, returning it, and displaying in the console. What happens is that when I call forward.getName, the first thing that happens is this is set to the object that is called. So when I called forward.getName, this is set to forward. The JavaScript engine will now look for the key on the object, so it's going to look for getName. It can't find it. If the key is undefined, it will move to the proto object, if not null. And so now what will happen is it will go up to call, because call is the proto object inside of forward. It will not be able to find it in call, and so now it will go up to getName or vehicle. It will now find the getName. And this has not changed any. This is still the forward object. And so that's why in this particular example, you actually get Mustang displayed out, because this is actually the Mustang object. So, you know, one of the things inside of your objects, you have to be a little bit careful about when you use this. A prime example is when you look at a lot of code and you have a function inside of your code, sometimes the this that is inside of it may not be the this that you think it is. And I'm going to show you an example of when that is. So as a good designer, forward, I actually want to change what gets displayed on my get name. What I actually want to do is display I love whatever my call name is, or whatever my name is. But you know, I don't want to have to define name inside of my object, because I know it's in my parent object, and you know, the function to get that is actually my get name. So rather than write all that code to do it, I can call my parent. And so that's what you see here. You see that I have object create call, and then I overwrote my get name to say return I love my, and here's call and the get name. So this is how I'm going to return the value of name from get name. So what I want to do is I want to copy this real quick. Okay, so got a question for whoever. Well, not many people on there now, just John and Steve. So John, what do you think will happen when I run forward.getName?
I was going to say I love my Mustang.
Nope. It says I love none. The reason being is that when I do a call.getName, this gets defined to forward to start off with. Then I fall into, I call my parameter, it looks for a getName key value, so I come into here. Oh yeah, I do have one. Okay, let me call this function. So it comes into here, and when you hit this call, this is a new object according to JavaScript. And so this gets changed to call. So now when I do a call.getName, it comes up to call, and it says, okay, can I find getName and call? No, I cannot. Let's jump up to vehicle. So now I'm in vehicle, and it says, okay, can I find getName? Yes, I can. But this is now assigned to call. It's not assigned to forward, because I did this call.getName.
Right. If you said this.getName, then it would have said, I love my Mustang.
All right. So if I come in here and say, change this like this, okay, and now I call forward, you can see it says, I love my car. The way to get around this in JavaScript is you actually would use a call function. So if I change this, redo this, and use this object, now I call forward.getName, it will say, I love my Mustang. The reason why that happens is call and apply will pass this object to, or the object that you're in, to the objects that you're actually trying to call. Okay, so...
Hey Jason, can I ask you a question?
Yeah. Yep.
Why would you do that as opposed to just saying return I love my plus this.getName? Would that not work?
No, it won't, because remember, well, I mean...
If you were to change that line to say plus this.getName.
Right, so, let's see here. So if I change this to this.
Oh, there's no function on this, is there?
No, that does work, because this is the object that I'm in, and then it will cycle up the tree. The problem you're going to run into is, what if I changed my parent object, the .getName, which is what I'm overwriting. So if I come in here now and I say vehicle.getName equal to function okay, so now on the forward.getName, you know, it doesn't happen. okay, because I never called my parent. So this is, if you're calling parent functions, how you can make sure you get the right this name. So let's retrain that. So now if I hit for.getName, it says I love my undefined because I didn't return anything in that function. So actually let's do this. Wow, and then we'll do a return of wow. So now I love my wow. Okay, because my parent class is now not concerned about this name. And that's not what it's actually returning. So, just understand that when you have this in your objects, that if you extend, or if you have this in your objects and you're going to extend, or you're going to extend your parent objects, a lot of times if you need to call the parent object as part of overloading or overwriting your methods, then you're going to have to call your parent with a call or an apply. The difference between call and apply is call will accept its parameters as just a common delimited values, where apply is an array of objects that you're applying. So this is how you pass items into the constructor of your parent objects. Okay, so one little last bit is that functions are nothing more than just objects. So if I take, actually I don't want to do it that way, I want to do this. Okay, so I created a, let's do it like this. Okay, so now if I do temp dot, you can see it displays just none. Okay, so that's the way you would expect a function to work. Same thing though if I do var dot xx equals, so now I do xx, you can see it says none. But one of the things the interesting thing about functions is that if I do xx.name, actually, I did this earlier. Let me change something real quick. Name is actually, for a function, is not valid. It's so I can't override it. So let's change this to text. Okay. There we go. Okay. So I have none. One of the interesting things, though, about these objects, if I do a console.log.xx, you can see that you have the object there. But I can actually do add a parameter to it. So now if I do xx.test, text, you can see I actually get a value back, but I can still call the function itself. Okay, so one of the things you'll find in Wismo with a lot of this stuff, since it's TypeScript created, is they'll have a function, and on the function they'll actually set parameters on that function. So it makes it interesting where you see something being called as a function, and then 5 or 6 lines down the road, you'll see it all of a sudden has parameters. Okay, and that can really make for some interesting headaches, is because you may not realize that your functions are also just nothing more than regular objects. Okay, so you can add more and more parameters to a function, and it will be treated just like an object is treated. And so this is just an example of you have two objects and then this. So when you call object 2, this val will be 200. Well, if you call this function, the val will be 100. If you call this directly, you get a undefined. So let's do that real quick. We're almost out of time. So if we go ob2, ob2.get. You can see it says 200. If I do ob2.1, it says 100. If I do you can see it says undefined. The reason why it's undefined is because this is not defined. So you return nothing in that instance. This kind of shows how functions are nothing more than just a regular object. In fact, if I do a console log of object 2, you can see my object is here. When you look at the get, you can see here I have my prototype. Finally, that thing showed up. You can see it created a name and a length for this automatically. The name is the name of the function, and the length is the number of parameters that you have in it. And then you have your prototype. So if you wanted to extend this function, you can actually extend it if you wanted to. Try this one more time.
I do have a question about prototype when you're ready.
Yeah, go ahead. Don't understand why that was working a minute ago. Weird.
I see prototype a lot, right? So as I'm digging through objects, trying to figure out what methods are available or whatever the case is, or what properties may be set to, that kind of thing. And typically I'm going to look through the prototype object, right? Or the prototype object, I guess. Is that always going to be the full signature of that object? So if I ever do my object.prototype, I should see all the properties and functions.
Prototype is a reference to the extended object. So if you create a regular object, so if I come in here and say var.x equals and then look at this actual object, you can see there is no prototype to it. It's just an object because this object doesn't extend anything. If I now come in and say var.y is equal to now say var.x is equal to object.create of y. Now look at x. You can see when I look at the proto object, it's actually my parent object. when you see prototype, I'm not for sure why in the console this isn't working quite right. It may be the version of Chrome I have. Even though I thought I got the latest, I may not have it. But when you do object.create like that, that prototype is actually the parent object. It's a reference to the parent object. So when you look at it and you see the prototype, that's your parent object. That's not the object that you actually are in. Does that make sense?
Yeah, it does. So it doesn't necessarily mean that it's going to show me all the properties and methods associated with what I'm looking at.
It only will show you what the parent. Yeah. So if we go back to this.
Yeah.
So this will be the structure. So when you look at call and you see call.prototype, that prototype is actually the parent object that you're looking at. And then that parent object may have a prototype, and that is what you're looking at when you look inside of that object.
Right, so if I do a prototype on car, I'm not going to see name or display name.
Correct.
I do a prototype on vehicle, I will.
Correct. Or no, no. When you look at car, and you look at prototype, you will see that vehicle object. So you'll see name and display name on the prototype object. When you look at call, the object itself, you won't see anything. So let's go back to this example. Whoops. Go get this example back up. Actually, let's go destruction. So take this object. And we'll create it, and then we will create a empty call, and then we'll create a call like that. So now we do a console.log of call. You can see we have an object displayed there, but there is nothing in here. That call is empty. If you look at the proto object, in the proto object you can see display name and name. When you look at vehicle, you look at this object, you can see here I have a display name and I have a name. When I look at the proto object, this is my null object that it is the parent of its parent. You can see inside of its parent there is no name or display name, but there are some default properties that we are privy to. So there is the constructor, value of, toString, get, and set. I wonder if that's why. Oh, I bet that is. Interesting. And so those are, it's parent's object. So remember, the prototype is nothing more than your parent object. And it's a reference to the parent object, because everything is being passed by reference.
Right, okay. I understand.
Okay, so one of the reasons why I wanted to go over this is because we're going to go over arrays on Monday, I think, or Tuesday. And arrays are specialized objects also. But when you think about scope in Angular, scope is nothing more than an object. And so when they create a root scope, all the scopes underneath the root scope is nothing more than doing an object.create with that parent scope attached to it when you create a new scope object. And so
root scope extended.
Yes. Well, on the top level. And then each individual scopes underneath it is an extended scope.
Right, okay.
So and that's why on a child object, if you can't find the scope item on it, then it will go to its parent and keep going up the tree until it either finds it or it runs into a prototype of null.
Okay.
The other thing I wanted to show is just how some of this works, because when you look at Angular, and especially if you look at jQuery or the Widmo stuff and you're trying to debug things, you do need to know how the objects are structured together and how you can go about finding things that may be on a parent. And the other thing, and like I said, I'm not 100% sure why string isn't working, because it's working on my other machine. But one of the things, oh, I know what we can do. Let's try this. X equals 1.2.3.4 x dot. Why do I have a feeling I'm not doing this right? Yeah, that's weird. They may have removed that for some reason. But you'll find, also might be because I'm in the console. Oh well. One of the things you'll find a lot of is people wanting to extend string or extend array or extend someone else's parent object because they need something. And so you'll see a lot of creating of the object.proto, and then that's how they actually extend the objects. So you'll find that actually quite a bit. Try something real quick, this performance. Yeah, they've removed it for some reason. That's weird. Interesting. Okay, so I'll have to research that. We'll see one of my version of, and it might be, oh, I didn't think about that. It might be because I'm using the Mac version of Chrome that I can't get to that prototype. I know on the Windows side I'm able to get to it. You can definitely get to it in the JavaScript, because you'll see it a lot in the Widmo stuff. Okay, so that's objects in JavaScript. Any other questions you have?
No, I'm good.
Okay. Once again, if you have anything you want to go over, it doesn't have to be just over Angular, that kind of stuff. Any kind of questions you guys have, just send them out and we'll do a meeting on it.
Okay.
Thanks, guys.
Okay, thanks, Jason.